In this video, let's talk about the divergence test, okay? And the divergence test is literally, it just says we're going to take a limit as n approaches positive infinity of the series an. And if the limit does not equal to 0, then we say an diverges. Okay, so that's just a simple uh, uh, kind of idea of the divergence test, okay? And so maybe if we're given a series like this where n is equal to 1 to positive infinity of 1 plus 1 over n raised to the n, okay? So the idea is if we take a limit as n approaches positive infinity of this series here of 1 plus 1 over n to the n power, well, this is a famous e. And so the limit of this is actually e. Well, e is actually 2 point something. And we know e, the limit does not equal to 0. Well, I don't know why I wrote this. So the limit is equal to e. The limit is equal to e. And we know e does not equal to 0. Okay, so the limit does not equal to 0. And so therefore we can conclude that this actually diverges. In fact, it does. So n actually diverges. So that's the general gist behind the divergence test, okay? Now how I usually know how to use the divergence test, and the first off is if I see a polynomial on both the top and the bottom. So let's give you a classical example. So what if we have k is equal to 1 to positive infinity of k squared plus k plus 3, and we divide that by 2k squared plus 1. Okay. Well, to me, again, immediately as I see a polynomial on both the top and the bottom, I'm always going to check for divergence. That's the first thing. And so if I take a limit as k in this case approaches positive infinity of k squared plus k plus 3 over 2k squared plus 1. Well, remember a nifty little trick from Cal 1. If the highest powers are equal on both the top and the bottom, then we simply take the ratio of the coefficients to be your limit. And so this is 1/2. There's a 1 here. There's your 1/2. So the limit of this is actually 1/2. Okay, 1/2 does not equal to 0. And so therefore we can conclude that n actually diverges. Now be careful here. This tells us nothing about convergence. Please let me repeat this point. The divergence test strictly tells us about divergence. It tells us nothing about convergence. So therefore, if the limit is equal to 0, we should not conclude that the series automatically converges. Okay, the divergence test only tests for divergence. Okay, exclamation point. Only for divergence. And here's the rationale. What if I have some sort of series where n is equal to 1 to positive infinity of 1 over n, and also another one where we have n is equal to 1 to positive infinity of 1 over n squared. Okay, well, notice that if I take a limit as n goes to positive infinity of 1 over n, well, notice that I'll get 0. My limit is 0. So I plug in infinity here, I have a constant on top, constantly getting bigger, so that's 0. Okay, well, what about this? If I take a limit as n approaches positive infinity of 1 over n squared, well, this also happens to be 0. Again, my number is getting big, so notice the limits are 0. Okay, but in fact, if we look at this, this is actually a p series, and so we know if p is greater than 1. Okay, in this case, p is greater than 1, so in this case, p is greater than 1 because p is 2, so 2 is greater than 1. We know that the series actually converges. Okay, in this case, well, p is less than or equal to 1. We know that the series, let's let me make sure I'm thinking straight here. From the p series, the p series tells us. Remember, the p series tells us that if p, let me make sure I'm getting this right here. So if p is greater than 1, and we have p is less than or equal to 1. So if p is strictly greater than 1, then the series actually converges. Okay. If p is less than or equal to 1, series diverges. So in this case, p is 2, which is greater than 1, so the series converges. Okay, so I just want to make that clear. 2 is greater than 1, series automatically converges. In this case, p is less than or equal to 1. In this case, p is equal to 1. And so in this case, the series actually diverges. And so that's the reason why this test only for divergence. Do not assume that if you get a limit to be equal to 0, the series automatically converges, okay?